Hey, today we're talking about translating inequalities. So real fast, do you like videos better with my face in them or not? Let me know. But here we go. So the left side of your screen is all of our words that we were using when we were translating word problems. The ones on the right are the ones that we're going to use for our inequalities. So this is a PDF that I will give to you in the notes for the lesson. So check out that if you want a copy to keep for yourself. Otherwise, you can just pause the screen and use this as a reference. So we're going to work on just 3 examples on inequalities, setting them up as from words to inequalities, and then actually solving some. So the first example is this one. Michael is going to the fair. In total, Michael can spend $35 on drinks and funnel cake. If drinks cost $1.50 and a funnel cake costs $5.75, we're going to let X represent the drinks and Y the funnel cakes. I'm writing inequality to represent the number of drinks and funnel cake he can purchase. So we're just writing an inequality here. We don't need to solve this. So it doesn't matter if these numbers are going to work out or not. We're just setting up the inequality. So what we're trying to do is first, we want to figure out, well, he has $35 to spend, and he is buying drinks and funnel cake. It doesn't say he's just buying one, he's buying multiple. Say he's giving them to his friends or whatever, it doesn't matter. So we need to set up our expression first. So what I'm going to do is I'm going to go ahead and set up both parts of the expression, and then we'll figure out what symbol to use in a moment. So first of all, we know that he has $35 in total. So on the one side, I'm going to put 35. Okay, that's dollars. On the other side, which I'm going to leave a box here, we have $1.50 for drinks, and funnel cakes are $5.75 each. So it says that X is going to be our drinks and Y is going to be our funnel cakes. So we need to set up an equation or an expression here to show that drinks and funnel cakes together should cost a certain amount of money. In this case, each drink is $1.50, so I have $1.50 per drink, which is X. And then each funnel cake is $5.75, and that's Y. And what he's doing is he's buying both of them, so we're going to add them together, and he has $35. So we're trying to figure out how many total he can buy. So in this case, we need to figure out what symbol would represent that at most he can spend $35. So if we want to think about it logically, we can do that, or we can use our reference sheet, which is here. So we're looking for the one where it's like the most money he can spend is $35. And I can see right here on my sheet that is at most is here. Okay, so this cheat sheet, I should say, works when the variables are on the left. So make sure your variables are on the left, or else this cheat sheet is not going to be helpful. Okay, so mine are on the left, and in the cheat sheet, it says that is at most should be a less than or equal to sign. So that means that at most he can spend this, or he can spend less than that. So the sign I want to put in here would be is the less than or equal to. And then if I'm writing this without the dollar signs, you could put 1.5x plus 5.75y, maybe, is less than or equal to 35. Okay, and that's all you would do for this problem, because all it wants is the inequality. It doesn't tell you to solve, which this would be difficult since we have 2 different variables. So we're not solving this. This is just the final step. The stuff in pink right here would be your answer. Right, so 2 more examples. So Stephanie just opened a candy store. All the candy in her store sells for $2. Her monthly expenses total $450. What's the minimum number of candy she must sell to make a profit? Well, we know that each piece of candy is $2. So each piece of candy is $2. $2 per piece of candy, right? And then she has total expenses for her store of $450. So we need to figure out what sign goes in the middle to represent that she needs to sell at minimum $450 worth of candy. Okay, so let's go back. We're looking for at minimum. So we're going to go ahead and erase that one. At minimum would be down here. It says it has the minimum value. So we need it to be at least that or more, which again falls in this category. So we want the greater than or equal to sign. So I'm going to go ahead and go back to the problem. And then I am going to go ahead and write, so we want the greater than or equal to. So we want at least this amount. And then we would solve this one because it says what's the minimum number of candies she wants to sell to make that profit. So When we solve this, we're going to go ahead and divide both sides by 2 because it's a one-step inequality. And then I have x is greater than or equal to 225. So that's x is greater than or equal to 225 pieces of candy. So this is telling me that at this amount, 225 pieces of candy is the exact number she needs to hit her monthly expenses. This is how much would she have to sell to make a profit. So I want to add one more. So the answer to this problem would be 226 pieces of candy. Okay, so it's wanting the profit. This is just minimum just to hit the expenses so she can keep her store open. But we want to make a profit, so we're going to do the 226. Great, so last problem. So this is a 5x7 picture frame. It needs a 5x7 picture, needs a frame whose width is the same on all 4 sides. If the frame's perimeter is 32 inches, what should the width of the frame be? So inside here, we have a 5x7. So I'm going to go ahead and label those parts in my picture. It does help if they don't give you a picture to draw one. So this is what a picture frame looks like. There's the outside of it, and the inside is where the picture goes. And then there's a thickness here that we are trying to figure out. We want to figure out what this yellow part is here. How thick is that? Okay, so I'm going to go ahead and put an X because we don't know that. So we have 5 inches by 7 inches. All right, and the whole perimeter here is 32. So what we need to figure out is, how do I figure out this number here? Okay, so first of all, let's figure out the perimeter of the inside, the picture. Okay, so step 1 is to figure out the perimeter of the picture. And to do the perimeter of the picture, you would just add all them together. Perimeter of the picture is 5 plus 5 plus 7 plus 7, which is 10 plus 14, which is 24. Okay, ideally you follow the order of operations here, but addition is commutative, so it's okay. So 24 inches for the inside. So I know that the inside here is 24 inches, and the outside here is 32 inches. So what I need to do is I need to figure out how thick this piece is, okay? So there's a trick here, and I am going to show you that trick just so you are aware of how to solve this. So each side here, to figure out the whole width of this piece, it's 2 times your length plus 2 times your width is supposed to be 32 for this one. Okay, however, we don't know what those numbers are. So what we are going to do is we can go ahead, our length here, okay, we have 7, but then we also have an X here and an X here to get to this whole length, okay? So that's X, that's X. Picture frames are always the same thickness the whole way around. Typically, I don't think I've seen a picture frame that is not, but it might be, I don't know. For these problems, they're the same width the whole way around. So for 7, the 7 inches, we have 7 plus X is our length. So our length would be 2 X's plus 7. For our width, I'll do orange. I already used yellow. Okay. And so for the width here, I have 5, then I have X, and I have another X. So this whole thing here would be X plus 5 plus X, which is 2 X's plus 5. Okay, so that's how you get the length and the width for this frame. So now I can go ahead and plug these numbers in and then solve. So I have 2 times my length of 2x plus 7 plus 2 times my width of 2x plus 5. And that should give me 32. And then I can go ahead and solve, distribute. So I have 4x plus 14 plus 4x plus 10 equals 32. Combine your like terms. So I have 8x plus 24, which, oh look, that's the perimeter from up here, okay, equals 32. Subtract 24 from both parts. Okay, so 32 minus 24. When I do that, you should get 8, but I am going to just verify with the calculator because I don't want to mess up. It is 8. And then you would divide both parts by 8. And it tells me that x is equal to 1. Okay, so that's telling me that the width of the frame is 1 inch wide. And then I can double check that. If I add 1 inch to each part of this, this is 5 plus 1 plus 1, so 5, 6, 7. This is 7 inches, this is 7, 8, 9, 9 inches. 7 plus 7 plus 9 will give me an answer of 32, which is what the original perimeter was. So I do know that my answer of x equals 1 inch is the correct answer here. Now, there is a quicker way to get to this answer that doesn't involve all of the distributing parts. You will notice that we have, now if this makes sense to you and the next thing I'm going to tell you is confusing, then just totally ignore what I'm going to say and just do it like this. But I know you like hints and you like cheats, so I'm going to show you it. So the perimeter of the picture is 24, right? Okay, well, it's right there. We already figured that out by adding it up. Now, the perimeter of the frame is 32, and that's right here, right? Okay, so what you could really do is make this into just a two-step problem. And you could take, originally, I'm going to put it over here. So you can start by taking 32 minus the perimeter of the picture, which is 24, to get 8. Okay, and then for every single problem with a picture frame, you are always dividing by 8. No matter what the numbers are, once you do your subtraction, you are always dividing by 8. Okay, because there are 8 different width pieces. Now let me just okay, so there's 1 here, 2 here, 3 here, 4 here. I'm going to erase these ones so it's not confusing. Okay, so I have 4 on the picture already. So then I have to also include, though, this one and this one. So that's 5 and 6. But then I can't forget down here, 7 and 8. So there's always 8 pieces that you're going to be dividing by to get that width for just the frame. So you would divide this by 8 to get 1. So really, this problem, instead of doing all of that distributing and all of that combining, you can shorten it and go straight to this step right here, where you're doing your subtraction first and then you're dividing by 8 every single time. That's the shortcut way. Okay, so either way you can use, but the shortcut way is going to be faster.